Welcome to Year 7 Chemistry. Helpful tips for working from home. Try to work in a quiet area. Read all slides and questions carefully. Remember, help is available if you get stuck. Teachers will be available to assist you between 9 a.m. and 3 p.m. Work will need to be completed and posted by the deadline. Today's driving question is, what is a chemical formula? Pause the video, try to complete the task. Match the word with the correct definition. If you're finished and you're willing to take on a challenge, complete the challenge. Suggest some differences between elements on the left and the right side of the periodic table. That's if you're up for the challenge, but you must complete the task. Welcome back. I hope you took your time in answering the questions, and I wish you all the best. The first word is atoms. What is an atom? An atom is the smallest part of an element that can exist. Element. What is an element? An element is a substance that is made up of only one type of atom. Compound. What is a compound? A compound is a mixture of two or more elements that are chemically bonded together. Mixture. And a mixture is two or more elements or compounds not chemically bonded together. I hope you got all four correct. If not, please stop and pause the video, make your corrections before moving on. Now, following with our driving question. There are over 100 different elements which are made up of atoms. We all know that all the elements on our periodic table, they're all made up of atoms. Elements can be divided into metals and nonmetals. Chemical symbols and formula are used to represent elements and compounds. What is a chemical formula? Remember that we use chemical symbols to stand for elements. For example, C stands for carbon, O stands for oxygen, S stands for sulfur, and Na stands for sodium. If you want just to verify that these are correct, you can pause the video and pull up your periodic table. If you want to search for a periodic table, you can access the AQA periodic table of elements. That's the required periodic table that we'll be using. Now, in molecules, we use chemical symbols to represent in molecules, we use chemical symbols of the atoms it contains to write down its formula. Now, based on previous lessons, we've looked at the word molecule. Can anyone remind me of what a molecule is? If not, a molecule is a neutral group of two or more atoms held together by chemical bonds, right? So in a group of atoms that are held together, we can use the chemical symbols of the atoms it contains to write down its formula. For example, the formula for carbon monoxide is CO. It tells you that each molecule of carbon monoxide consists of one carbon atom joined to one oxygen atom. But please note, take care when writing your symbols and formula. Be careful about when to use capital letters. For example, CO means a molecule of carbon monoxide, but capital C, common O, is a symbol for cobalt, which is an element. So if you are writing the chemical symbol for an element or compound, please be careful when selecting your symbols. Numbers in formula. We use numbers to show when a molecule contains more than one atom of an element. The numbers are written below the element symbol. For example, carbon dioxide is a formula for CO2 is the formula for carbon dioxide. It tells you that each molecule has one carbon atom and two oxygen atoms. That's what the formula is telling us. So if we look, we can see we have one carbon atom, and for every one carbon atom, we have two oxygen atoms. Take care when writing these formula. The small numbers go at the bottom, for example, in CO2. This way is correct. However, if you write the small number at the top, it will be considered to be incorrect. So always remember, the subscript numbers go to the bottom of a symbol. Now, on to the real thing. How many physical and chemical changes can you spot? I can spot a few. I can see one, the smoke coming from the chemical factory. Two, the smoke coming from the car, and these two are chemical changes. Three, I can see the ice melting. This is a physical change. Four, I can see that bubbling is taking place and steam is given off, which is a physical change. I can see that heat is being generated, which is another chemical reaction. I can see that both the male and the dog are carrying out respiration, which is a chemical reaction. But what is a chemical reaction? Chemical reactions do not only happen in the laboratory. Chemical reaction can happen anywhere that new substances are made. For example, in cooking, rusting, sticking, burning, making metals, and actually living. Yes, also in living. Can you think of any other chemical reactions? There are ton of chemical reactions that are happening around us every day. Many chemical reactions are useful or even essential to survival. For example, combustion, which is burning, fermentation, making bread and alcohol, useful chemical reactions, ripening of fruits, electrolysis used in metal plating, neutralization, removing acid or alkaline, smelting, which is for making metals, polymerization, making plastic. Right, those are just a few examples of many useful or even essential reactions that we need in our everyday lives. Non-useful chemical reactions. Some chemical reactions are a nuisance or can be dangerous. For example, pollution causing acid rain, pollution causing the greenhouse effect, the spoiling of food, the rusting of steel, and those are just to name a few. In a chemical reaction, one or more new substances are formed. The starting substances used in a reaction are called reactants. The new substances formed in a reaction are called products. The aramines changed into in a chemical reaction, all the reactions change into all the reactants change into products. So what we have on this side of the equation, our reaction, must be equal to this side of the reaction in terms of its product. So again, the reactants must be equal to a product. This leads us back to what we call the conservation of energy, where energy cannot be created or destroyed, but is converted into one form or another. So we might have two things reacting here, and when these two things react, they form one. But at the end of the day, the two reactants can be found in the one product. It is difficult to reverse a chemical reaction and change the products back into the reactants. Chemical changes are usually difficult to reverse. Magnesium burns in oxygen to form magnesium oxide. It is not possible to unburn the magnesium once it has been burnt. This is what a Redet equation looks like. Magnesium plus oxygen is equal to magnesium oxide. Many reactions, they do need energy to get them started. So as you can see, we have two reactants here. These are the two substances that reacted to give us the product, which is the magnesium oxide. From this product, we can identify the two reactants that were used, which were magnesium and oxygen. Heat energy being given out is one sign of chemical reaction. What are other signs of chemical reactions do you know? A few examples are a change in color, a change in smell. You might see bubbles from mixing substances, or even a change in temperature. Now, even though we're used to seeing this one arrow, some reactions are irreversible, while some reactions are reversible. So this arrow or this symbol is used to represent a reaction that can be reversed. However, in most cases, this is what we will be seeing because not every chemical reaction can be reversed. A word equation. A word equation is used as a quick shorthand way of writing a chemical reaction. There are always three parts to a word equation: the names of the reactants, an arrow, the names of the products. What is the word equation for hydrogen reacting with oxygen to form water? Let's read that again. What is the word equation for hydrogen reacting with oxygen to form water? Take a look at what we have up top. The reactants equals the products. What two things were used to form the product? In this case, the water will be the product. What were the two things that were used to form water? Hydrogen plus oxygen equals to water. So the two reactants were hydrogen and oxygen, and the product was water. In this chemical reaction, which substances are reactants and which substances are products? This is a simple chemical equation that you will look at further on in your school life. Magnesium plus copper oxide is equal to magnesium oxide plus copper. Which two substances are the reactants? Which two substances are the products? First one, magnesium oxide. Which section of the equation does magnesium oxide fall? Did it fall on the side for reactants, or did it fall on the side for products? Magnesium oxide is a product. Now that we have done the first one, take a minute and try to predict magnesium, copper oxide, and copper. Are they reactants or are they products? Awesome. Magnesium. To which side of the equation does it belong? Does it belong to the product side, or does it belong to the reactant side? So magnesium would be a reactant. Copper oxide, is it a reactant or a product? It is a reactant. And copper, would copper be a product or a reactant? It would be a product. Awesome. I hope you guys got everything correct. If not, please pause the video and make your corrections. Now, these are a few simple examples that I want you to attempt. So pause the video, give yourselves 5 minutes to complete the task. Welcome back. I hope you have timed yourselves. Now, what are the word equations for the following reactions? Number 1. Magnesium burns brightly in oxygen to form magnesium oxide. Which two substances were used as the reactants? And which one substance was created as the product? Always remember the product is a mixture of two or more substances. So in this case, the reactants would be magnesium and oxygen, and the product would be magnesium oxide. Number 2, calcium hydroxide reacts with hydrochloric acid to form calcium chloride and water. As you can see, in some chemical reaction, we will have more than one product. So in the question, or in questions 2 and 3, we will have 2 products. So again, number 2, calcium hydroxide reacts with hydrochloric acid to form calcium chloride and water. Which 2 substances would fall under the reactants side and which 2 will fall under the product side? So as we can see, calcium hydroxide plus hydrochloric acid are the reactants. Therefore, the products should be calcium chloride and water. Question 3. Sodium reacts with hydrochloric acid. From that point of view, you can tell which 2 substances already will be the reactants. Reactants are the 2 substances that react together to create a product or products. So again, sodium reacts with hydrochloric acid. So that will make sodium and hydrochloric acid the reactants. Therefore, sodium chloride and hydrogen would be the products. Awesome. And again, remember that the arrow means that these reactions are not reversible. We cannot reverse these chemical reactions. Now, a quick note for you to always remember. I want you to pause the video, take a minute or two, find a family member in your household, try to memorize these simple definitions. 1. What is a chemical reaction? A chemical reaction is a change in which new substances are made and cannot easily be reversed. Products. The new substances produced in a chemical reaction and shown on the left of the word equation. Reactants. The starting substances used in a chemical reaction and shown on the right of the word equation. The last one, word equation. A word equation is a summary of a chemical reaction. I want you to pause the video and give yourselves 5 minutes to memorize these 4 words. You will be seeing them very, very soon. Welcome back. Now, a little activity. Chemical reaction quiz. Chemical reactions take place everywhere. You have to decide if the following common reactions are useful or not useful. Combustion. Is combustion useful? Not useful reaction or useful reaction? What do you think? Let's go with those who said it is not useful. Bet your luck. Next time, sport. So it simply means that combustion is useful. Combustion has many uses, including powering vehicle. So without combustion, your vehicles will not move. Acid rain. Is acid rain useful? Think about it. You have acid rain. Is that useful or not useful? Again, let's go with not useful. You're correct. Acid rain is caused by pollutants dissolved in rainwater and can cause damage to buildings and plants. Polymerization, making of plastics. Is it useful or not useful? Think about it. Is making plastic useful or not useful? Let's go with useful. Ooh, you are correct. Polymerization is a useful reaction involved in making plastics. Smelting. Is smelting useful or not useful? Let's go for not useful. Oh, bet a lot next time, sport. Which simply means that it is useful. Smelting is a process that can be used to make metals from metal ores. Neutralization. Is it useful or not useful? What do you think? Is it useful or not useful? Let's go for not useful. Better luck next time, sports. It's useful. Neutralization is the reaction used to treat indigestion. The alkaline tablets neutralize the excess acid in the stomach. So whenever you have acid or stomach burns or heartburns, we take alkaline tablets to neutralize the acids. Electrolysis. Is this process useful? Let's go to not useful. Ooh, better luck next time. Spot on. Electrolysis is used to extract metals from their ores and to stop other metals corroding or to make them decorative. So the little fancy earrings, bracelets, chains that you're wearing, yes, without electrolysis, they wouldn't be possible. Yeah? Remember that. Fermentation. Is fermentation important or not? Think about baking your bread. Is it useful? Let's go for fermentation is useful. That's right, you got it. Fermentation is a process used in making bread or beer. Rusting. Is rusting useful? Let's go with useful reaction. Better luck next time, sport. Simple means that it is not useful. Rusting is the reaction of iron with oxygen from the air to form rust, in other words, form iron oxide. Ripening of fruits. Is this important or not important? How important is ripening your fruits? Let's go with not important. Ooh, better luck next time. So it's useful. When fruits ripens, many complicated chemical reactions take place in the fruits. Right? Well done. Useful reactions: combustion, smelting, polymerization, fermentation, ripening of fruits, electrolysis. Not useful reactions include acid rain and rusting. Now, I want you to pause the video and have a go at this passage. If not, let's go through the passage together. In a chemical reaction, the starting substances are called the. What is the name given to the starting substances in a chemical reaction? What is the name given to the starting substances in a chemical reaction? Let's have a look. Is it reactants, equations, or products? Equations, products, or reactants? Let's go with reactants. Awesome. Next sentence. One or more new substances are always formed, which are called the. When we have two substances reacting to create something new, what is the collective name given to the new substance? Is it A, reactants, 2, equations, 3, products? Is it reactants? We've already used reactants, so let's take that off the list. So we have equations and products remaining. Let's use products. Awesome. Like sentence. It is dash to change products back into reactants. Remember what I said about the arrows. Is it very easy to convert our products back into reactants? Easy, difficult, often, possible. Easy, difficult, often, possible. Let's go with, I think I'm hearing some of you guys are saying easy. Let's go with easy. Let's see. Second paragraph. A chemical reaction can be described in words, anagram, summary, equation. So a chemical reaction can be described in a word, anagram, summary, or equation. Let's go with the word equation. Second sentence. There are often visible changes during a chemical reaction, such as bubbling, oxygen, melting. Let's read it again. There are often visible changes during a chemical reaction, such as bubbling, oxygen, melting. So oxygen is an element. Melting is changing from one state to another. So let's go with bubbling. Dash is given out during many reactions and is often required to start a reaction. Most reaction requires, is it A, hydrogen, 2, oxygen, 3, energy? Let's go with energy. So let's read this to see if it makes sense. In a chemical reaction, the starting substances are called the reactants. One or more new substances are always formed, which are called the products. It is easy to change products back into reactants. A chemical reaction can be described in a word equation. There are often visible changes during a chemical reaction, such as bubbling. Energy is given out during many reactions and is often required to start a reaction. Let's see if we got it correct. Dun, dun, dun. Oh, we got easy wrong. Always remember, a chemical reaction sometimes it's not possible to reverse. All right. So what should this one have been? Difficult. Let's have a go. Well done. Now that we have completed the lesson, please go to Google Quiz and complete your quiz. See you next time.